Lesson 4.5, Scatterplots and Correlation. How do you determine if there is a correlation between two variables? There are three different types of correlation that we're going to talk about in this section. There's positive correlation, negative correlation, and no correlation. We're also going to talk about how you draw the line of best fit for a set of data that has correlation. So positive correlation is the first graph because the data points are going up in a positive pattern, like a positive slope, rise from left to right, positive correlation. The dots are kind of clustered together so that there's a pattern where the dots are going up from left to right. Negative correlation is like a negative slope. So the points, the dots are scattered, but they are in a pattern where they're going down from left to right. And then no correlation is when they are scattered all around the graph, so there really is no pattern at all. The relationship, when you say, how do you determine if there's a correlation between two variables? Correlation is like a relationship. And with positive correlation, both variables are doing the same thing. So if one variable goes up, the other goes up. So both variables go up or both go down. So as you can see, as you get further across your x-axis, these points up here also have very high values on the y-axis. So both of the variables are going up. They're increasing. So as x increases, y increases along with it. If I draw a line of best fit through these data points, I'm going to use my line drawing tool. It kind of looks to me like the pattern is like that. A line of best fit, you are not going to draw the exact same line as a person sitting next to you. You just want to make sure that your line goes through the trend, So you have some points below your line, some above your line, some might be on your line. There isn't a requirement. It doesn't have to go through 2 points or 3 points. You just draw it through the trend. On the negative correlation, through the trend, maybe looks like that. And then when there's no correlation, you cannot draw a line of best fit. There is no correlation. On my negative correlation, what's happening for each of these variables? As I move along the x-axis and I get higher, the y values actually go down. So as one variable goes up, the other goes down. That's a negative correlation. It's like a negative relationship between the two variables. So it's not the same thing happening. If x goes up, y goes down, or if x goes down, y goes up. I can add that over here. And I can say, or as x goes down, y goes down. Because with the positive correlation, the relationship between the two variables is that the same thing is happening to both variables. No correlation, there's no relationship, so you can't draw that line of best fit. You can't draw it at all. So my line of best fit is shown on my graphs with my line drawing tool. And it means a line through the trend of the data. What a line of best fit is used for is for making predictions about values. So if you draw the line of best fit, you can make predictions for any value that's on that line, or you could even extend your line past your data points and make predictions into the future. Okay, this is just a multiple choice question. Which of these shows the best line of fit for the scatter plot? This is something that you could see on a standardized test. And if you look at all of these lines, really only one of them makes sense. A line of best fit cannot look like this. It has to just be a line. A line. It's not a line graph. It's not a dot to dot. This line that's horizontal, clearly the points in this scatter plot are not horizontal. So that line does not make any sense. This line for A, this line is going down. It's going down, showing that they see a negative correlation. There's definitely not a negative correlation on that graph. Those dots are in an upward pattern. Now, I'd like you to take a look at B, the correct answer, because you may be concerned because there's a point way down here that they left out. They left out. Now, the reason that they left that point out is because that point is called an outlier. And when you draw your line through the trend of your data points, you are allowed to ignore outliers. You are allowed to ignore them. So you may have been thinking that the line of best fit should go something like this. But the problem is that line is going to be a lot steeper than the trend really is. So this line, where they have it drawn, is actually most accurate. It went through a couple of the points, and there's only one on each side. So that is the line of best fit when there's an outlier in your data. That's why we wanted you to see this example, because outliers you can ignore. You can ignore. Okay, determine if this graph shows correlation. If it does, draw a line of best fit and describe the meaning of the situation. Well, hopefully it's pretty clear to you that there is a negative correlation in this graph, and it looks like a line of best fit would go about here. It's almost linear. It's almost linear. You could move it down a little bit like this. I kind of ignored the 2 points that are up here above the graph because I want my line to go through the trend, and the trend to me, those are very tight. So I would say this is a strong negative correlation. Strong because it's almost linear. It's almost linear. Weak would be if they were more spread out. So it's a strong correlation and it's negative. I drew my line of best fit. Now I just need to describe the meaning of the situation. My variables, I've got years and I've got students per computer. Students per computer. Remember, negative correlation. As one variable goes up, the other goes down. So what I notice is that as time goes on, the number of students per computer in Maria's school goes down. So as time increases, so as time goes on, because that would be increases, the number of students sharing a computer at Maria's school, I got that from the title, is decreasing. So basically that means that they've got more computers. Over time, their school has gotten more and more and more computers, so the students don't have to share them anymore. Okay, this next problem, same directions as the last one. My line of best fit, right there. It looks like it's pretty much linear. So, and this is increasing from left to right. So, strong positive correlation. Because as one variable goes up, the other one's going up. And describe the meaning. This says years Our independent variable is years again. And number of prescriptions in the millions. And the title says mail order prescriptions. Little typographical error on that. Strong positive correlation. So, over time, more people are using the mail to get their prescriptions. That's what's happening on this graph. So make sure when you explain your situation, you're reading each axis label and the title to make sure that you can put meaning on the situation. The next one, this correlation does not look as strong as the others. So here's my line, but I'm just going to call this a positive correlation, not strong positive. And the meaning of this situation, it says calories burned during exercise, time, again the independent variable, and calories. So this is telling me the longer, because it's time, the longer you exercise, the more calories you burn. Okay, another negative correlation because this one's going down. And I think I'll adjust my line a tiny bit. Okay, so this one is a negative correlation, not strong, again, because it's not really close to being linear. So we will just go with negative correlation here. And describe the meaning. It says weight in pounds and the number of repetitions, and it's called weightlifting. So this is telling me that the more weight that you're lifting, the fewer repetitions you are able to do. The heavier the weight, that's a better word to use. The heavier the weight, that you are lifting, the fewer the reps you can do. Now this graph is something new. We have not seen one of these yet. This one's got no correlation. Those points are scattered all over that scatter plot, and there is no pattern. So this tells me, so I can't draw a line of best fit, but this tells me that if I look at the graph, there is no relationship between the number of books borrowed and the fine at the library. So there is no relationship. No correlation between the number of books borrowed and the fine from the library. Because if you're familiar with books at the library, it's not the number of books, it would be which books you're talking about, because there are some books that are really expensive and there are some books that are very cheap. So it's not about how many, it's about which books they are. that you have if you're going to be fined for them. Okay, I think we've seen enough of these, so you should be ready to write a summary now. And then we have a Scatterplot packet to work on for your homework.